All right, so number 20, I was actually giving you the base formula of the x minus h squared minus or divided by a squared minus y minus k squared divided by c squared equals r squared. However, this one's a little bit easier because everything's at the center. When the center is the origin, what was that coordinate again? 0, 0. So when the center is at the origin, you don't have to worry about H and K, which is what I was kind of getting to there at the end. Um, so the formula would simply just be x squared over a squared minus y squared over c squared. No, b squared, sorry. B squared equals 1 because if it's at the origin, the radius is going to be 1, and then 1 squared is 1. So this is the basic formula. The one we were using is the same concept. Actually, it's always equal to 1, Wendell and hyperbolus and parabolus. You don't got to stress about that. What you stress about is these things. What you have to remember is that vertices represent the A, and the foci represents the C. So if I'm trying to find the B, I need to go through the process of X and Y stays the same. It's part of the equation. So the only thing you got to go find is A and B. A is given 2, but not C. So the way we do that is we use the Pythagorean theorem formula. C squared equals A squared plus B squared. And then we learned from our modulus that we can just take the square root to get our answers. And so now to solve for B squared, I'm going to plug in what I know for A and C. So C is 5. A squared is 3 plus B squared. Then you go through the process of just solving this. What's the first thing I need to do to get B by itself? Square it, which I could have probably started there. Oh, it's not going to matter because when I go back and I square it, what's 5 and negative 5 squared? 25. So it's not going to matter at the end. So I don't stress about the negative. I just throw in the positive version. Yes, the foci and the vertices are, well, no, only when the origin's 0, 0. We have another problem that will come up in this review that they're not the same, but we'll just find the distance between them by subtracting them. So like we'll do x1 minus x2 and then find out where their distance is. So I'm going to square both sides here. So this gives me 25. The square root and square will cancel. 3 squared happens to be 9. So therefore, what I do next to solve for b? Subtract the 9. So I get 25 minus 9, which is 16. Good. Now, I could then go through and figure out what the square root of 16 is. That's a b squared. There's a lag there. But what I'm looking for is b squared. So I could, then I just have to square it right back again. So instead of doing that, I can now see that my b squared is 16 and 3 squared was 9. So that's how I get to this point here. What y'all got against junior high? Y'all came from the junior high. We're all one big district here. I don't think he's in the 8th period. Bless you. Savell again, last name? I don't know any Savells over there. I do think I know of a Savell just looking at data because she's in Algebra 1 and that's our hyper focus there. But I don't personally know them. All right, so any questions on that? So again, this is just going to be one of those ones where when you're making your flashcards, you see the word hyperbola, you kind of go to this question. A squared, right? A squared is the vertices, so 3 squared would give me 9. The only thing I didn't know was B because you're given the A and the C, so you have to like pretty much you're using the Pythagorean theorem. Basically, what you're doing is you're producing a triangle on the graph, and you're just trying to figure out what that point would be. Kind of like what we did with our vectors. When it's a hyperbola question, yes. A parabola, I believe, is also a minus, but a circle or ellipse is a plus sign. So this right here would be the equation if I said this was an ellipse. Because what it does is if this is a hyperbola, bless you, the graph is going to look something like this. If I put a plus sign in between it, what it does, it changes the direction of this. So now I get an ellipse. That's why that minus or plus mean the formula is the same. It's bless you again. It's literally the same thing: x squared over a squared, y squared over b squared. But for ellipse, now it's a plus sign. I know in algebra 2, I usually make this a hyperfocus, but in pre-cal, I never really got into it. But that was way back in the day. All right, number 21. Going back to sequences and stuff. So this is, again, a sequence of 7, 12, 17, 22. The sequence above is defined for all natural numbers. What is the sequence expressed using a recursive formula? A recursive formula is basically a formula that would help you find the next number. We have a, what's the other formula? Recursive, and then I can't remember the other one. But the other one helps us define any number in the sequence. Recursive just helps you find the next one. So basically what you're doing here is you don't even care what kind, if it's arithmetic or geometric, you're just trying to figure out which one of these would give me the next number. So meaning a sub 1 is the first term, so that's 7, so that should be a given. They should all say that. If none of them say it, you can cross them out. Then you just look at the math. If I want the next number, is that 5 times 7? No, so that's out. Bless you again. This right here. Okay, so what this means, this is a sub 1, right? We understand that means first term. So if I wanted to know what the second term is, that would be a sub 1 plus 1. 2. So when I'm doing that, I'm looking for the second term. So that would mean it's 5. Term, I would do 5 times the first term. That's what these n plus 1s mean. So this right here just represents the nth term, and this right here would be the next term. Like if this was a sub 7, then this would be a sub 8. N plus 1 just represents the next term in the sequence at any given time. So I could have asked this question like this. I could have said, hey, what's a sub n plus 1 equals 5 a sub n, where a sub 17 equals 42, right? Instead of me having to figure out that pattern, and I just wanted to know, hey, what's the 18th term? I can come over here and say, well, that's going to be a sub 17 plus 1, because that equals 18, right? So then I can, all right, well, that's a sub 18 now. And if I replace this n with a 17, I have to co-replace this a with a 17. And so now that if this is a sub 17, I now know it's 42. The answer would be 5 times 42. That's all the n plus 1 represents, is what is the next term. Okay. So when you're dealing with recursive formula, you will always have that n plus 1. Let's say that. You could technically have n minus 1. That would happen here. But that's usually not until college. So in this case, this next question says, to get the next term, do I do 7 minus 5? No. This next one says, do I do 7 plus 5? Yes. And then just to check it, this one says, do I do 7 divided by 5? No. So to get the next term, what operation do you have to do? That's all that question's asking. Am I adding? Am I subtracting? Am I multiplying? Am I dividing? That's it. And see, does that give you second term? If it does, boom, that's the answer. If it doesn't, now I will tell you this, I doubt it does this, but do check it. You could get the second term on B and C, but then the third term doesn't work out. So you'd want to say, all right, is it going up by 5 every time, or is it being multiplied by 5 every time? Forget what situation that. Let's say it's being multiplied by 2, but let's say the pattern starts off as 2, 4, 8, right? If I try to go from 2 to 4 and I see a sub n plus 2, that would work, right? But would I add 2 to get 8? No, so I'd be looking for the times 2. So do watch out for patterns like that that might work for the second term. Just make sure it progresses through the rest of it too. Now this one had 3 failures and only 1 pass, so that was pretty easy. I just try to see if it works out for the next turn. So for instance, if the pattern was like 2, 4, 8, right? And then I had an answer choices over here as a sub n plus 1 equals 2 a sub n. And I also had a sub n plus 1 equals 2 plus a sub n, given that a sub 1 is equal to 2. 2 times 2 is 4, and so is 2 plus 2. Both of these would have worked. So then you want to try the next one. So then I would plug in 4, and I see that 2 times 4 does give me 8 versus 2 plus 4 would have gave me 6. So then I would say that one's wrong. So just watch out for things like that. I don't know if this test is going to try to trick you or if it's just going to ask basic questions. I really don't know. I'm really hoping it's just going to ask the basics. Just make sure you understand the concepts and not go too much into detail. But I don't know. All right, number 22, this one says the linear function is defined by f of x equals 2x minus 4. The unique function g is defined by f of g of x equal to x and g of f of x equal to x. For all real numbers, which of these functions represent the function of g? So basically what you're doing is you're just trying to figure out which one of these functions can I plug into this function to get x out of it. So, and I'll do a couple of them with you. So meaning I would come over here and I would say, all right, if I take this and I plug it in for x, that'd be 2 times 1/2 x minus 2 minus 4. I'm going to replace that x with whatever this function is. And then I'm going to see, does that give me x or not? So when I kind of distribute here, what's 2 times 1/2? Just 1. So this is just 1x. 2 times -2, -4. But then -4 minus 4 gives me what? -8, right? So that didn't give me x, so that would be wrong. So then I try the next one. And I'll go 2 times 2x plus 4 minus 4. And I'll go through the same process. 2 times 2x would give me 4x. It said x right there. So 2 times 2x was 4x. 2 times 4 is 8. But then when I simplify this, what do I end up getting? 4x plus 4. Not what I wanted, so that's not it. So then I try the next one. And I go, all right. This is now 2 times 1/2 x plus 2 minus 4. Distribute. What's 2 times 1/2? 1x. 2 times 2? 4. And this time, when I go 4 minus 4, I would be left with 0x, or just the x itself, which is what I was looking for. So therefore, that's my answer. That's all this question is asking. Is which one of these functions can I replace that x with so that when I simplify, I just got the x? You don't know this, but this means that these two functions are inverse of each other. But that's not what the question here was asking. Go ahead.
Okay. Okay. So I thought we were plugging into the.
I did. Yep. I did. So to play whatever the answer choice was. No. I'm replacing the x with the functions, and I'm trying to get x as the answer. Perfect. Yeah. So I'm not trying to get this as the answer. I'm trying to get x's as my answer. So again, this question is basically just asking which one of these. That's all it's asking me. So whichever one to simplify down to straight up x. This gave me x minus 8, not what I was looking for. This gave me 4x plus 4, not what I was looking for. The next one gave me just an x, which is what the directions told me to do. Yeah, only into the parentheses. This -4 rides down to the next step. Yeah, only multiply to what's inside the parentheses. And that's why we use parentheses when we plug in to show multiplication or distributive. Yes, ma'am. It should also equal x because it says it there as well. Yeah. Any other questions? So that would be an alternative way you could do. Since both of these are supposed to equal x, you could technically take this equation and plug into each one of these x's to see which one gives you x as well. That'd be another way. All right. Number 23. What the 17th term of the arithmetic sequence if the common difference of the sequence is 7 and the first term is 12? So you'll notice there's a lot of arithmetic sequences here, so make sure you have that equation memorized. Y'all remember it from the last 2 days? Does anybody? So when y'all been studying with y'all's flashcards, arithmetic sequence is what formula? This is definitely going to be a test you're going to want to be studying for. We did it yesterday, and I think we did it the day before. Correct. If you don't have it memorized or start it or highlight it, write this formula down. Arithmetic sequence is a sub 1 plus d times n minus 1. This is where all linear functions come from. Okay, I'll write it out again. This represents the first term. This represents the difference. And the n technically would represent the nth term, if you knew what the nth term was. Now, in this case, you do. Yeah, this time you do. It's actually asking what is the 17th term. So that would be your n. In the arithmetic sequence, if the common difference of the sequence is 7. So the 7 would be my d, because that's my difference. And the first term is 12. So that'd be my a sub 1. So it gives you all. Go ahead. It does, but what if I ask you to find the 117th term? It would take you 30 minutes. But if you have this formula, then you can just plug it in and just solve it. So this would be 12 plus 7 times 17 minus 1. Isn't this a little bit nicer than going 12 plus 7 plus 7 plus 7 17 times? Yeah, what sometime, yeah. So in this case, the nth term would be a term I'm looking for. I don't know what it's called, so I call it the nth term. In this situation, I'm actually looking for the 17th term. So my nth term is now going to be considered 17 because now I know what I'm looking for. So just like we say, hey, what does X represent? We don't know what X is. Bless you. Man, is there allergies going around? It's black mold, I'm sure, right here. Oh, yeah, it can. So like this right here, you can see the water going in the other day. That's pretty cool. So we'll look. Oh, I should look at the lights too long. But anyway, so X is just something we don't know. The in here is just something I don't know yet until it was told to me. Hey, I want you to go find the 17th term. Oh, cool. Now I know in is 17. That's all it represents. So in this case, PEMDAS tells you 17 minus 1. Oh, not PEMDAS. PEMDAS tells you do what first? What's the first thing? Or GEMDAS, however you learned it. Parentheses first, right? So 17 minus 1 is 16. Do I have any exponents? What's the next thing? Multiplication. I have to multiply before I can add. Don't make that mistake because I guarantee you it's probably one of these questions, the answer choices. So what's 7 times 16? You could type it straight in as you see it as well. 112? And then 112 plus 12 would be 124. But I bet you anything, 19 times 16, it would. And I don't know if it's actually there because 6 and 9 would be a 4. Huh? 304. But I wouldn't put it past them to have that number there. You did all the work to remember the formula, but then do PEMDAS wrong or something. Any question there? So again, we've done this problem 3 times now. So this is a very important formula to know. It's not a hard one. A1 plus D times N minus 1. That's just a little flashcard thing you can just tell yourself. So make sure you have that down. And the key word there for that one is arithmetic. You see that word arithmetic. All right, the next question is, what's the range of this function? Anytime you're asked for a domain or range question, grab your calculator, graph it, and just look for yourself. So yeah, it does that. Sine and cosine are called sinusoidal waves. Sinecoidal, sinusoidal waves, or whatever like that. But it just makes these waves like this for shock waves, music waves, sound waves, things like that. If you ever go into yeah, forever. If you're well, look what the question's asking for. What's the question asking for? What is the range? How high and how low is it? Domain, yes. If it did ask for domain, my answer would be infinite because it would continuously go on. But this is asking for the range, which is the bottom of a graph to the top of a graph. So let's graph it real quick. Let's make sure we know how to do that. Left to right, range is bottom to top. This would be 3 trig sine x minus 5. Oof. So I'm going to do menu 5. 1 is your number 1 command. So I'm just going to kind of, and you can go as far left or right as you want. You might want to do this. I think this looks better. You do Windows Zoom Fit, or maybe even because it's trig, menu Windows trig. Yeah, there he goes. That looks better. Yeah, so bottom to top. So again, when you're dealing with the trig function to kind of help y'all out, menu, zoom, trig. I know this is trig because it has a sine away, but you don't have to. You can always do menu 5-1. And you can actually click this mouse and you can actually move your graph up and down. But I'm looking for what these guys are. So again, I'm going to do menu 5-1. And you could have done this right from the get-go. It doesn't really matter. But I'm looking at the Y value. So I'm looking at that second number. And I'm just trying to figure out what is the largest and smallest number I see. So I'm going to go up to the top. Left and right. Yeah, it does go really slow. But I can kind of see if I look at that Y value, I'm at negative 2.01, negative 2, and then it goes back down. So that tells me right there what's my largest Y value. Negative 2. So I can kind of look at this and go, well, bam, it has to be C. Right? Or I could go the opposite direction. I could have gone down and saw what the smallest value was and kind of gone from there. Eventually I'll get there. Usually it's fast, sometimes it's slow. I really don't know. Maybe. These graph questions should be the easiest because you're literally just looking at it. So negative 8, I can see as my smallest. So again, I'll restart that question as if I just saw this for the first time. I said I'm going to do 3 trig sine x minus 5. Again, maybe I forget all the zoom tricks. The only command you need to really remember when it comes to graphs is what? Menu 5-1, which is trace. Very good. And so again, I didn't do any special zoom. I'm just going to just move this arrow up and I'm just going to pay attention to that Y value. I see that it's going up. Oh, There's -2 right there, but then I see it's going back down. So that right there alone would have told me that -2 is the highest value. Huh? The X? What do you mean? I'm not understanding the question. Uh-huh. You mean the Y? Right, yeah. No, the -8 and the -2 would both be Y values. So when I went over here, I looked and I saw -2 was the largest Y value. So then when maybe I keep going to see what oh, look, and the maximum actually showed up there. Where'd it go? Right there. So that tells us that that's the max. Go ahead. Yes. So then if I kept on going, yep, that yellow thing disappeared. Oh, where'd it go? Yes, and you'll actually get that every single time, no matter where you're at. So I can see that my Y value there is -8. So I'm not looking at the X value since I'm looking at the range. I'm just looking at the second number of my coordinates. Yes, because -8 is smaller than -2. We write numbers from least to greatest. So it has to be -8 to -2. Now, granted, most of your answer choices will be that way. I don't think I've ever seen them written the other way. So basically, if you could just figure out which one the max and the min is, most likely you already got your answer. But just in case they try to trick you, then you can just kind of keep going with it. Any questions there? So menu 5-1 on grass is your number one friend. It answers all questions for you. All right. Number 25, which of these is a true statement? Trying to think what's the best route here. I can do one of two things here. I can teach you what a reciprocal identity is. That's the one part we didn't get to, but unit module 4 would have taught you all the different trig identities, or I can show you how to use the calculator. Because if you can remember the identity, it's actually quicker. What you would have to do to have the calculator do the answer for you is you would have to graph the left and the right side and see if it covers it. So like this. So I would try A. I would say, all right, what is sine X? I would graph it. I get some random black line. Yes. And then I'll do tab, and now I'm going to type in the second one. So that's going to be control. Yes, that's it. So then I go secant. Secant is located right here. And so is that pink on top of the black? So that would be the wrong answer. So then I would try the next one. If y'all like that method, I'm good with that. Yeah. And so now that I got that, I'd probably open up another graph, do the same thing. I'm just going to kind of skip ahead here, show you what it does look like when you do get the answer. So there's tan X. Tab. I'll then do control divide 1 over cotan X. And I can see the orange went around top of the green. That's the way you could do that answer. Does anyone want to see the identities or care right now? Yes. Well, it's called inverse inverse identities. So sine X is equal to 1 over cosecant X. Cosine X is equal to 1 over secant X. Tan X is equal to 1 over cotan X, and vice versa. Cosecant X would be equal to 1 over sine X, and secant X would be 1 over cosine X, and then cotangent X is equal to 1 over tan X. This is actually one of the very first identities you're taught because they're super straightforward. Basically, the way I memorize this is S and C go together. So sine would not go with secant. Like it has to be an S and a C. And then tangent and cotangent have the word tangent in it. So then I remember that one. That's how I memorize it for the thing. But if you have that memorized, then obviously you can easily find the answer without having to type it in the calculator bunch. But if you like the calculator technique, good either way. Well, good. Anyone need more time to write those down? All right, number 26, you're asked to find the angle A. For the angle A equal to 2 pi thirds in quadrant 2, a reference triangle with a reference angle is shown below with the unsigned lengths of each side of the triangle. Use the diagram to show the value of sine A. So basically, again, it's telling you that this angle is your sine. What this question's really asking is what is sine of 2 pi thirds? Two pi thirds. Remember, sine is the y value. So what's my value? Yeah, that's what this question's asking. So when you're given something like this, it's simply just saying if the angle is equal to 2 pi thirds, what is sine of 2 pi thirds? And you just use your reference and identify your answer. That's called a unit circle. Is it right? I'm allowed to. I just know you're not allowed to have any notes, phones, of course, things like that. Calculators allowed. I am working on trying to get a reference sheet, but the only reference sheet I can find is an Algebra 1 reference sheet, which I still think I might attach to the test because who knows, you might need it for something. Any questions there? So as I can see, if I scroll down, square root of 3 over 2 was the answer. All right. All right, number 27. Again, I could show you all the different ways to simplify trig identities using your trig identity functions, or you could do exactly what we did 2 problems ago. You would plug this into the calculator, and then you would plug all of these into the calculator to see which one goes on top of each other. So I'll kind of show that as an example one more time for you. But I would go here, open up a graph, control, divide. So notice that says sine squared x. When you do it, you have to do sine. For the calculated purpose, the square has to go outside of the x, not in between the sine and the x. You'll get an error code if you try that. That's the only thing about this calculator. And I'll do cosine of x next. And I get some type of brown line or whatever. So then I'll do tab. I'll do A next. I'll do trig secant x minus. Absolutely. Give me a second. You can see that blue line did go right on top of it, but this does say select 2 correct answers. So do make sure you go and find the other one.
Yes.
What did you put in there?
I put what you put.
No, you put the square on the inside.
Oh.
The square wants to go on the outside. Oh, you can't put that. The square has to go on the outside of the X. Yeah, there you go.
I just pushed enter over there. Whatever you put.
Oh, because now it's squared it. Hold on. Why does it get extra parentheses here? There you go. Oh, where does this go?
It is holding my hand.
Yes.
Oh.
It's actually super easy, but you have to know your trig identities. We didn't get to teach that. Are y'all getting that too? I want, or what mode are you in? Degree? They're in radians. I wonder if that means something. But it's not going to matter because I think you can, as long as you stay in radians, you should be able to type the other ones and still get the same answer.
Okay.
I think that's the issue. And you got that. I don't think it's going to matter. You can either get this or the parabolas. That's what it is. With a bunch of asymptotes in there, that's connecting them. But when you type in these answer choices, because it's still in radiant, it'll be right on top of it. Yeah. Yeah. So even if you got the whole bunch of U's, keep it that way. It's fine. There's no biggie. It's just because I'm in degree and y'all are in radiance. But as long as you stay in that mode, when you put the next graph in, it will, if it is the same graph, it'll be the same graph. Right? So we're good there. So do watch out for this type of question. It says select two. Don't just say, hey, that's the answer, and then you moved on. Make sure you read the entire question. Do you want me to show you how you can do it by hand? Okay. If you want to know, I can definitely show that. Like I said, if you know your identities, it's super easy and quick, but you have to learn it. And I'll be honest with you, I didn't really learn my trig identities until I was in college because I didn't understand it in high school myself. It wasn't until college that she was like a drill sergeant on these things and forced us to like memorize it and stuff like that. And it helped me learn it. I had to learn like tricks of the trade. All right. Number 28, I have a graph. What do you think I'm going to do? Just graph it and then just see which one looks like it. That's it. So these are the ones you should definitely get correct. Make sure though, before I do move on, make sure you can type this in correctly and get this graph. So go ahead and practice that concept and make sure your graph looks like that. Because again, some people might not know how to put a power of X, make a fraction, things like that. Does everyone know how to make a power of X? What button do you push? The rooftop, caret, whatever you want to call it. And that makes it the X tiny. Because once y'all start the test and you ask me what button do I hit on the calculator, my response to you will be, I'm sorry, but I cannot help you with that. Gotcha. Perfect. Thank you. Where's my calculator? That's probably not the route I would go. I would just say 2 parentheses, control divide. I like to type it just like I see it because I don't want to make any errors. And then when I'm outside the parentheses, I hit the rooftop button or the caret in computer science. Then it makes that little bitty small box up there. And then I'll hit X. If you do E, as long as you delete the E, it probably does. But I would get nervous that something in the background of E is still there and I might get a skewed answer. And then because I don't really know what I was doing, I might think that's my answer and that'd be one of the answer choices I get wrong. Any other questions on how to put that in? All right. Things like these graphs, they might look pretty close in similarity. Just pay attention to where it crosses like the y-axis. Is it a growth or a decay? Means it going up or down? Does it cross the y-axis? Things like that. Or my bad. It crossed the, pay attention to where it crosses the y-axis. See that it didn't cross the x-axis. See this one's going the opposite direction, but crosses the same spot. This one looks like it's going the same direction, but not crossing the same spot on the y-axis. And then this one here looks pretty darn close, but doesn't quite cross at the 2, right? So they're going to look similar. Just pay attention to some characteristics on your calculator. All right, number 29. So again, I told you like that took like 3 pages alone because it was like a graph per paper. Number 29 says, what is the solution to this? Again, I could show you how you can solve this. This is actually a college algebra concept. So if you do take my course next spring, I'll definitely show you how you can use this by hand. But for pre-cal purposes, all you got to do is just graph it. Let's practice doing that. You'll graph up to that inequality sign, but don't actually graph the inequality sign. What you got?
No, I keep like entering on accident, and whenever I get to the 2, it like stops. So I gotta do.
Oh, just hit tab. Oh. Now you can edit.
Shoot.
Yeah, if you are working on your graphs and you accidentally hit enter to get out of it and it graphs it, just do tab, then up, and you can edit whatever you just did. I do that all the time sometimes. Because what I'll do is I'll hit the arrow out too many times. It'll knock me out. So, all right, here we go. So this is going to be x to the fourth plus 2x to the third. Make sure you arrow out, making it look like what you're seeing on paper. You don't want it to look like it's getting tinier and tinier. That's not going to give you the correct answer. 3x squared minus 8x minus 4. Stop at the inequality symbol. Do not graph the inequality symbol. So I'm just going to hit enter. You know what? Yep, because it's blocked. Can't put an inequality symbol in there anyways. Or you will, and it'll give you some type of error. This is asking, where is this true at greater than 0? If something's greater than 0, is that going to be above or below the x-axis? Above. So you're going to look at this graph and tell me where is it greater than or above the x-axis, basically. So when I look at this, I can see that this part of the graph is above the x-axis. Yes? So that would mean that everything to this direction is all above the x-axis. So that would be negative infinity to whatever that value is. If you don't know what that value is, what's your number one command? Menu 5-1. Bless you. So what I'll do is I'll go right up there to that spot, which is a -2. So that tells me from negative infinity, from the left side of the graph is always negative infinity, to -2. As you can see, negative infinity to -2 are both here and here. Left and right. So then I go to the other side. Obviously, all these are below the x-axis, and then from 2 on, I can see is above the x-axis again. So this will now be 2 to infinity. So you'll notice A and B are exactly the same thing. Can anyone notice the difference? Parentheses, very good. Can anyone tell me when you have a line underneath an inequality what you're supposed to have? A bracket. So if you have an inequality symbol there that has a line, it has to be a bracket. If you get a less than or greater than with no line, it gets parentheses. And it's an Algebra 1 concept, and we've seen it a lot since then. But these little inequality lines would get the brackets. Oh, so when I'm looking at the left side of the graph, we call that negative infinity of um the what?
Looking at like the left side, back line, left side of the white.
Y-axis, yeah. I got you. I see what you mean. Yeah, so everything to the left of the y-axis represent negative infinity. Everything to the right of the y-axis, the positive infinity. You're technically looking at the x-axis when we say that, but I understand your concept of visual aid. So left of the y is negative infinity, right to the y is y-axis, but it's basically paying some sense to the, because as you can see, this is like -10 and it just keeps on going. Go ahead. Mhm. Where the numbers came, right. So I'm looking at what this value is because the question's like, when is this function greater than 0? To be greater than 0, that means it has to be above, right. So it has to be above the greater. Oh, I see what you mean. Oh, yeah. Technically, this would be incomplete because technically you would include -1 into your answer. That's a good point. Yeah. No, that would actually be correct. It should actually say negative infinity to -2 union -1 to -1 union -2 to infinity. But technically, it is missing one part. But yeah, no, totally didn't even catch that. But yeah, no, so yeah, you would be correct, but they just didn't have that as an answer. So in that situation, just like any other type of test, which one's the most correct? And this one would be more correct than that one, or the closest, yeah. But yeah, you are correct. It does say equal to, so -1 should have been there as the answer. Go ahead.
So
I'm only looking at the x value. I don't care about the 0. The 0 is this 0 because you're looking at when is this graph greater than or equal to 0? Well, that happens at 2, and that also happens at -2. That's equal to 0. And then any number I keep going, this y value would be greater than 0. So for instance, if I come back over here, so notice I put a 2.1, my y value gave me 3.94. That's greater than 0. I put 2.4, I got 20.3. That's greater than 0. I put 2.7, I get 45. That's greater than 0. So any I put in there, I would get 0 or greater. Is that us? Where does the fun go, man? This class flies by. All right, I'll probably leave some questions for y'all to do tomorrow, and we'll continue this discussion on Monday. Y'all enjoy the rest of the day, guys, and enjoy y'all's weekend.